You don't always have control over the CAD systems your partners or suppliers use, but you'll often need to make in-house edits to their data. Most 3D systems don't offer any tools to make even the simplest of edits. Solid Edge with Synchronous Technology 2 lets you edit imported data as if it was originally created in Solid Edge. Starting with this Solid Edge assembly, we'll add a bearing support that came from a supplier using Inventor, but could have come from other 3D systems such as SolidWorks or Pro Engineer. Intuitive assembly constraints mean parts are accurately positioned relative to existing components. Next, we add a standard motor and gearbox assembly that raises and lowers the cutters. The motor was defined in SolidWorks, but that does not stop Solid Edge from using the data as though it was a native model. With the parts in place, you can see the green bearing holder doesn't fit, so let's refine the design. Imported geometry loses all creation definition, such as features. Without features, most systems simply can't make complex selections. Fast edits require fast selection, and using Solid Edge with synchronous technology, you can fence an area or select based on functional or geometric conditions. After selecting the star-shaped flange, which also includes the mounting holes, the geometry can be easily copied to other models or stored into a feature library for later reuse. Now that we've captured the mounting details from one part, let's look at how they can be used to redesign the bearing mount. Reusing the flange and mounting holes is simple. A quick drag from the feature library adds the geometry to the part. Placement is precise using key point snapping, and using existing geometry as a guide guarantees the correct fit and position. Remember, no features were needed for this process. Let's refine the bearing holder originally designed with Inventor some more. To ensure the part fits tightly with the motor housing, we'll simply 3D stretch the flange on the bearing mount until it mates with the motor. Details such as rounds and chamfers are easy to add. Just click the desired edge and the results are shown in real time. A quick grab and go is used to thicken the flange. Notice how the rounds are maintained. As we strengthen the base of the new bearing mount, watch how Live Rules finds and maintains some key geometric conditions. Notice how all coplanar faces are moved along with the original face. Even though this part was imported, you can still make precise changes using 3D driving dimensions. These dimensions also provide directional control, locking, and can be used with equations. Watch as they maintain critical distances when the mounting feet are rotated. Solid Edge with Synchronous Technology 2 also lets you make assembly-level edits across multiple components. Watch as the holes in the bearing housing and the mount plate are moved in real time. Because Live Rules ensures the whole model updates, only a couple of faces need selecting. A blue highlight tells you which geometry will change. Notice how concentricity, tangency, and symmetrical geometry conditions are maintained even though we only selected the hole and the corner radius of the two parts. Only Solid Edge with Synchronous Technology 2 has the power to edit imported data faster than the supplier.